Welcome to The Explainer. Today, we're diving into something truly incredible, the engineering secrets of the International Space Station. I mean, think about it. It's a whole city just floating out there in, well, the most hostile environment you can possibly imagine.
All right, just imagine this for a second. You're up there, floating 400 kilometers above Earth. It's totally calm, totally quiet. And then, a crackle over the radio from Mission Control, and they deliver a message that would make your heart just stop. No time to move the station. None. The crew had to scramble, literally run for their lives to their escape pods, their lifeboats, really. All they could do was get in and just brace for what could be a catastrophic impact. You know, this crazy close call really shines a light on two things: just how dangerous space is, but also the absolutely brilliant engineering that keeps those astronauts safe. So that's the big question, right? How in the world does a structure this size of a football field survive in what's basically a cosmic shooting gallery? So let's be clear. That whole incident back in 2012, that was not some freak one-in-a-million accident. It's a constant, terrifying threat they live with every single day. Because get this, the ISS is hurtling through space at just a mind-bending 27,000 kilometers per hour. And to give you an idea of what that speed means, a collision with something as tiny as a single grain of sand at that velocity hits with the force of a bowling ball slamming into a wall at 100 kilometers per hour. A grain of sand. So yeah, the stakes are just impossibly high. Okay, so to really understand how the ISS survives all this, you've got to wrap your head around just how big this thing is. We're talking about one of the most ambitious, most incredible construction projects humanity has ever pulled off. It's one of the heaviest things we have ever managed to put into orbit. I mean, it's a true heavyweight champion up there in the cosmos. And that price tag? Well, it represents a massive global investment. This wasn't just one country. This was a commitment from nations all over the world to come together and push the boundaries of what's possible. And this number right here is maybe the most important one. It represents its incredible success. Think about it. Since November of the year 2000, there has not been a single day, not one, without people living and working on board. A constant human outpost among the stars. You know, this thing didn't just launch in one piece. No way. It was built piece by piece, module by module, while in orbit. And the whole thing started as this amazing collaboration between, get this, former Cold War rivals, the US and Russia, joining forces to create this incredible international marvel. All right, so you've built this giant city in space. Awesome! Job done, right? Well, not quite. How do you solve the most basic, most fundamental problem of all? What are the astronauts gonna breathe? I mean, sure, you could just send up tanks of oxygen from Earth, but that is wildly expensive, not to mention risky. What happens if a launch fails? The crew could be in very, very serious trouble. So from the get-go, the ISS had to be a self-sufficient life support system. It absolutely had to make its own air. And the way it does this is with a process you probably remember from high school chemistry class: electrolysis. But, and this is a huge but, there's a twist. In zero gravity, gas bubbles don't just rise to the surface like they do here. They just kind of hang out. So the machine has to spin like crazy, using centrifugal force to literally fling the precious oxygen out of the water. And this is where the true genius of the system really kicks in. Absolutely nothing goes to waste. That leftover hydrogen from making the oxygen, it gets captured. Then it's combined with the carbon dioxide the astronauts are breathing out, and the result? More pure water, which of course can then be turned right back into oxygen. It's this perfect, beautiful, self-sustaining loop. Okay, so we've got air, the crew can breathe. That's a big one checked off the list. But what about that terrifying debris storm we talked about at the beginning? How do you deal with that? Well, to handle that constant threat, the ISS has a really clever two-part defense plan. See, it's not just one problem. It's facing two totally different kinds of threats all the time. On one hand, you've got this constant hail of tiny, sand-sized particles you can't even track. On the other, you've got the less frequent but totally catastrophic danger of larger junk, old satellite parts and stuff. And you need a completely different solution for each one. So for that first problem, that constant barrage of tiny stuff, the ISS basically wears armor. It's this multi-layered shield that works a lot like a bulletproof vest. The first layer is designed to hit the particle so hard it just vaporizes it. Then the layers behind it absorb all that energy, keeping the crew and the inside of the station safe.
Okay, but for the big stuff, the car-sized threats, armor isn't going to do a thing. The only option is to dodge, to just get out of the way. Mission Control is tracking thousands of these things 24/7, and if one gets too close for comfort, they have to physically move the entire station. Which leads to a pretty big question. How do you steer a city in space when you don't have a giant engine?
Right, because using rocket thrusters every time would just burn through their limited supply of fuel like crazy. The real solution is, well, it's way more elegant. It's something straight out of a physics textbook, and honestly, it is absolutely brilliant. The secret sauce, the key to this whole magic trick, is a principle called angular momentum. If you've ever played with a spinning top, you've seen it. It just wants to stay spinning, stay stable. The ISS basically takes that same idea and uses it on a massive, massive scale. Okay, so deep inside the station, there are these 4 huge gyroscopes. They're basically just really heavy flywheels spinning at over 6,000 RPM. Now, by just slightly changing the speed and angle of these spinning wheels, the engineers on the ground can transfer all that powerful spinning energy to the station itself, and this causes the entire massive structure to slowly, gracefully pivot out of the way. And the best part? It's all powered by the sun. No fuel needed. All right, so there's one last piece to this incredible survival puzzle: communication. For years, this was a huge, huge problem. Every time the ISS went around to the far side of the Earth, boom, radio silence. They were in a total communications blackout, completely cut off from mission control. Today, though, that problem is pretty much solved. Instead of sending a signal down to Earth where it can get blocked, the ISS beams its signal up to a whole network of satellites that are way higher up. Those satellites then act like a relay team, bouncing the signal around the globe until it reaches mission control. The result is a near constant connection with only a few seconds of delay. It's amazing. So when you look at the whole picture, the International Space Station is so much more than just a floating laboratory. It's a proof of concept. It proves that we can solve the deadliest, most impossible challenges of living in space with pure human ingenuity. But, and it's a big but, its lifeline to Earth for things like food and supplies is still absolutely critical. And that leaves us with the next great question, right? The one the ISS is helping us prepare for. As we set our sights on Mars and beyond, how do we finally, truly cut that cord?